In this lesson, we're going to be taking a look at the last part of section 8.1, and our goal in this case is to see, again, when we're in a binomial setting, when can we use our normal approximation tools that we learned in chapter 2, and how would we use those tools. So we're going to be starting on page 530 in your book. We're going to look at problem 8.24, and it's called Checking for Survey Errors. You're going to need a pencil and paper and calculator, so take a minute to gather those items and read the problem. Okay, if you've read the problem, you know that in part A, we're looking for the mean and standard deviation of x. In this case, x is measuring the number of blacks in a random sample of 1,500 adults. To compute the mean, we're going to use the formula mu equals n times p. In this particular case, n, the size of the sample, is 1,500. P is the percentage of blacks that we expect in the sample, which is 0.12. Multiply those out, you get 180. So if we took a random sample, we would expect to have 180 blacks. What we don't know is how variable that number is. So to calculate that, we're going to use sigma. The formula for sigma is somewhat similar. It's the square root of n times p times 1 minus p. From the previous question, we already know what n and p multiplied together are. But we're going to basically say 1,500 times 0.12, just like before. But we're also going to multiply by 0.88, which is 1 minus p. And when we simplify all that on a calculator, we're going to get approximately 12.5857. So that means that we would expect to have 180 blacks in a typical sample, plus or minus about 12 or 13. That's part A. Okay, let's move to part B. In part B, we have to check to say, is this particular distribution smooth enough that we could use our normal approximation tools? And in this case, what we're going to use is a comparison test. We want to see if n times p and n times 1 minus p are both greater than 10. If they are, then we can use the normal approximation. Well, we know n times p was 180 from part A. So that one is definitely greater than 10, so that checks. N times 1 minus p would be 1,500 times 0.88. That's going to be 1,320, which is also obviously greater than 10. So the normal approximation is okay to use here. You have to show this particular check every time that you want to use it, or at least once within the context of a problem, to show that using the normal approximation tools are okay to do. Now that we've done that, we can go ahead and take the context, or the problem in this context, which is we'd like to find how likely it is that a typical sample would have between 165 and 195 black people in it. So we want to start with 165. That's going to be our first x. We're going to calculate z for that, and that's going to be 165 minus 180 divided by 12.5857. And if you're wondering where I came up with those numbers, that would have we would have gotten those out of part A. We get negative 1.19 by that calculation. Then, if we do the same calculation for the other x, which is 195, looks very much the same, except in this case, we have a positive z since we're above average, and it's going to actually be the same z, just on the positive side, 1.19. All right, so at this point we have the two standard scores. Now all we need to do is make a quick sketch and find the area that we're looking for. So here is the normal curve that we said we could use. It's got 180 here in the middle. That's a z of 0. And if we go 1.19 on either side of that, that would give us a big chunk here in the middle. And so the z on this side is negative 1.19. And then here's z is 0. And then 1.19. So now we need to use either table A or the calculator or whatever we're going to do, but we're going to find that this area is 0.7660. That would indicate that the probability of having between 165 and 195 black people in our typical sample would be 0.7660, which means it's fairly typical.